Okay, great. So last time we started looking at the double angle identities. And we found exact values for the two tangent 157.5 divided by minus tangent squared over of 157.5 degrees. How do you think we could use double angle identities to find the exact value of 2 sine of negative 22.5 degrees times the cosine of negative 22.5 degrees? Yeah, so we're gonna, just for clarity, we're gonna let alpha equal negative 22.5 degrees. And we want to find 2 times alpha. But first, let's rewrite this. This will become 2 sine alpha cosine alpha. And do any of the formulas for the double angle identity match with 2 sine alpha cosine alpha? Oh yeah, that's right. So the first one, sine 2 alpha, is exactly this pattern, 2 sine alpha cosine alpha. So we need to find 2 times 22.5. So we have 5 and 4. So twice 22.5 is 45, and we've got the negative. Where does this angle live if it's a negative 45 degrees? Where are we on the unit circle? Where are we on the unit circle if the angle is negative 45 degrees? Which quadrant are we in? Keep sending your answers via chat. I know one of you is doing that already, but yeah, keep doing that. That helps. Yeah, so the negative means opposite direction. The normal direction is counterclockwise. So the opposite would be clockwise. And we always start at the positive x-axis. So I know if I go all the way to the y-axis, that's 90 degrees, so I'm going to go halfway. And what are the coordinates of this point on the unit circle? The one of you who was texting hasn't texted again. So please text, or I mean chat, or you can text me the coordinates of the point on the unit circle at 45 degrees. So we're in quadrant 4. Ben, you are a co-host.
All righty.
Thank you. So yes, we're in quadrant 4. We're at 45 degrees in quadrant 4. That means that we've got 2 over 2 square root of 2 over 2. And in quadrant 4, x is positive, y is negative. So what is the value then of the sine of negative 45 degrees? Which one does the sine go with, x or y?
Goes with y.
Very good. So we have negative square root of 2 over 2. And just because I want you to keep this in mind, that's the same as negative 1 over square root of 2. Great. And let's just try this together. How would we find 2 times the sine of 15 degrees times the cosine of 15 degrees? Which of these formulas are we going to use? Yes, good. So we're going to use sine 2 alpha is 2 sine alpha cosine alpha, because that's exactly the pattern we have. We have the same angle, and we have 2 times sine 15 times cosine 15. So let's see. We know that 2 sine alpha cosine alpha is equal to the sine of 2 alpha. And here alpha is 15 degrees. So 2 alpha is 30 degrees. So one of you is using the chat to answer, and I appreciate that. So keep it up. Everybody, you can do that without muting yourself. And just quickly, I'm going to see if this is a student. Oh, yes, it is. A second. Okay, here. So that means that we want to find the sine of 30 degrees. 30 degrees. Let's see. 30 degrees is 1/3 of the way. And 30, remember, is the same as pi over 6. 45 is the same as pi over 4. So what are the coordinates of the point at pi over 6 or at 30 degrees on the unit circle?
Square root of 3 over 2 and 1/2.
Beautiful, thanks. So that means that the sine of 30 degrees is square root of, is 1/2, because sine goes with y. And that means that 2 times the sine of 15 degrees times the cosine of 15 degrees is also equal to 1/2. Which is pretty cool. Let's look at example 4. So we have that beta is in quadrant 2. So there's beta. And they tell us that the sine of beta is 12 over 13. can we find a triangle associated with beta? And can we fill in the missing side of that triangle? Yeah, sure. We're always going to think of the reference angle when we think of an angle that is greater than 90 degrees. But often we put beta in this place rather than beta prime. They're the same angle. So if we know that we've got this triangle with beta prime as the angle or beta as the terminal angle here, how can we use the fact that sine of beta is 12/13 to label some of these sides? Yes, great. So we know that sine is opposite over hypotenuse. So opposite will be 12. Hypotenuse will be 13. And we just need to find A. So A squared plus 12 squared is 13 squared. And we'll subtract 144 from both sides. We get that A squared is 25. What do we need to do to find A? Good. We're going to take the square root of both sides and put in a plus or minus. So we get plus or minus 5 equals A. And in quadrant 2, is A positive or negative? Keep putting answers in the chat because that's really good. That helps. Good. So in quadrant 2, A is negative. So we know that A is -5. And now let's go back to the question. We want to find sine 2 beta, cosine 2 beta, and tangent 2 beta. So let's start with the sine 2 beta. Using the formula, we know that sine 2 beta is 2 times the cosine of beta times the sine of beta. And I think I read that backward, but it's the same. So we've got the sine of beta. They gave us that. What is the cosine of beta? In terms of the sides of a right triangle. Good, thanks. So we know that cosine is adjacent over hypotenuse. The adjacent is -5. And the hypotenuse is 13. And we would write this as -5/13. We want that negative to be out front, just because it makes it easier to use the number. So we've got 2 times 12/13 times -5/13. 12, 2, and 5 do not reduce 13. So the denominator is going to be 169, 13 squared. The numerator is going to be twice 12 times -5. So I've got a negative out front. 12 times 5 is 60. what is 2 times 60? All right, so we've got that the sine of 2 beta is negative 120 over 169. To find the cosine of 2 beta, let's use the first cosine formula. Cosine squared minus sine squared is cosine 2 beta. So cosine squared beta minus sine squared beta. And we know what this the sine of beta is. We know what the cosine of beta is. So we've got negative 5 over 13 all squared minus 12 over 13 all squared. And when you square a negative number, do you always get a positive?
Yes.
Good. Okay. So we've got 5 squared, which is 25. 13 squared is 169. 12 squared is 144 over 169. We already have a common denominator. And let's see, we've got 144 minus 25. Why did I do it in this order if the 144 is the negative one? Yeah, good. So when you're subtracting numbers that have different signs, you always put the larger one first, subtract the smaller one. The answer has the sign of the larger. Oh, good, we get to bar. So 14 minus 5 is 9. 3 minus 2 is 1. We bring down the 1. So we know that the cosine of 2 beta is negative 25 over is negative 119 over 169. If the cosine is negative and the sine is negative, what quadrant is 2 beta in? Yeah, good. So the quadrant that has negative x and y is quadrant 3. So we know that 2 beta lives in quadrant 3, which means that the tangent of 2 beta should be positive. Let's find the tangent of 2 beta 2 different ways. Let's use the formula. There we go. So we know that the tangent of 2 beta is 2 times the tangent of beta divided by 1 minus tangent squared of beta. So for this one, we need the tangent of beta. Let's see. And we're going to use the sine over cosine definition. So let's see. Sine, we said, was negative 120 over 169. And cosine was negative 119 over 169. What can we multiply numerator and denominator by to get rid of this complex fraction? Yeah, and what about
169 over?
Yeah, thanks. So the negatives divide out. Negative divided by negative is positive. And we can multiply by 169 over 169 to divide out the denominators of the complex fraction, and we're left with 120 over 1/8. Okay, I want to do something just for fun. Let's find sine squared of 2 beta plus cosine squared of 2 beta. What should we get? Yeah, we should get 1. So let's see. Sine of 2 beta, we said that was negative 120 over 169. And we're going to square that. And cosine of 2 beta, we said that was negative 119 over 169. We're going to square both of those. And we're going to leave the 169 squared as just 169 squared. In the numerator, we should get that same value. So let's go ahead and see what that is. Can somebody pop that into, or I can just cheat and pop it into my calculator. 169 squared. Squared is 28,561. Okay, good. So that's the numerator that we want to get. And now we've got to square 2 other big numbers. The negatives, do they go away because of the squaring? Okay, great. So we want to find 120 squared and 119 squared. And I'm going to cheat again. Let's see. 120 squared is 14,400. And 119 squared is 14,161. That's our numerator. So we've got 14,400 plus 14,161. And when we add those together, we should get 28,561 because that's the denominator and that's how we'll get 1 overall. So let's see, 14,400 plus 14,161. Well, we're already kind of happy because we can see that the last 2 digits are 61, and that's good. That's what our goal is. 4 and 1 are 5. 4 and 4 are 8. 1 and 1 are 2. And we do indeed get 28,561. So numerator and denominator. Are 28,561, which is 1. So these bizarre looking sines and cosines do indeed still give us 1 when we square and add. I think I do want to do this one other example. So if we have that the sine of alpha is 2/5 and that the tangent of alpha is positive. First of all, which quadrant is alpha in? Okay, so yes, if sine is positive and tangent is positive, then this alpha must live in quadrant 1. That's kind of boring. Let's do the try this, because here we've got cosine alpha is negative, tangent alpha is negative. What quadrant is alpha in? For the try this 5. Yeah. Cosine is negative in second and third. Tangent is negative in second and fourth. So we must be in the second quadrant. So that's where we're going to draw our triangle. And we know that alpha goes from the positive x-axis to this terminal side, and that the reference angle for alpha, which we're going to call prime always, is in quadrant 2. So let's finish off our triangle. And we're given that the sine of alpha oh no, we're given that the cosine of alpha, oh good, that the cosine of alpha is -4/5. In terms of the sides of a triangle, cosine is adjacent over hypotenuse. So let's see, the hypotenuse is going to be 5. It's always positive. Hypotenuse is always positive. So the adjacent must be the negative part. And that makes sense because in quadrant 2, the adjacent or the A side is negative. To find the B side or the opposite side, we're just going to use the Pythagorean theorem. So we know that -4 squared plus B squared is 5 squared. So 16 plus B squared is 25. That means that B squared is 9. Because 25 minus 16 is 9. When we take the square root of both sides, we have to throw in the plus or minus. But in quadrant 2, B is positive. So we know that B is actually +3. And that's great because we've got all 3 sides of our triangle. When we have all 3 sides, we can answer any question. So let's see. We want the sine, here we go. We want the sine of 2 alpha, the cosine of 2 alpha, and the tangent of 2 alpha. And we are going to use the all the values for alpha. So we know that cosine of alpha is -4/5. The sine of alpha is opposite over hypotenuse. So it's opposite over hypotenuse. The sine is 3/5. Tangent is opposite over adjacent. Opposite is 3. adjacent is -4, but I want that negative out front. So we've got the three values for alpha. That means that we can use these three values, the three identities. So let's see. We know that sine of 2 alpha is 2 times sine alpha cosine alpha. We just said that the sine of alpha is 3/5, and that the cosine of alpha is -4/5. So in the denominator, we're going to have 25, and then 2 times 3 times 4 with a negative. So let's move this over and make that negative. 2 times 4 is 8, times 3 is 24. So we have that the sine of 2 alpha is -24 over 25. To find the cosine of 2 alpha, let's use one of the other identities for cosine 2 alpha. Let's use 2 cosine squared alpha minus 1. Sorry about that. So we've got, let's see, cosine we said was -4/5. So we get, let's see, -4/5 squared is positive 16 over 25. 2 times 16 over 25 is 32 over 25. And I'm going to write 1 as 25 over 25. Let's see, 32 minus 25. Oh, goody, we get to borrow. So 12 minus 5 is 7. We're left with 7 over 25 for the cosine of 2 alpha. So let's see. We said that the sine of 2 alpha is -24 over 25, and that the cosine of 2 alpha is 7 over 25. Since the sine of 2 alpha is negative and the cosine of 2 alpha is positive, we know that 2 alpha lives in quadrant 4. That means that the tangent of 2 alpha should be negative. Let's find it in 2 ways. First, let's find the tangent of 2 alpha as the sine of 2 alpha divided by the cosine of 2 alpha. And we said that the sine of 2 alpha was -24 over 25. So we have the sine of 2 alpha is -24 over 25. The cosine of 2 alpha is 7 over 25. And if we multiply by 25 over 25, we see that these inside denominators go away, and we're left with -24 over 7. So yes, indeed, the tangent is negative, which it should be in quadrant 4. Now let's find the tangent of 2 alpha using the tangent formula. 2 tangent alpha divided by 1 minus tangent squared alpha. And I'm going to write tangent squared alpha as tangent alpha squared, just to remind myself that that's what tangent squared alpha means. And we said that the tangent of alpha was negative 3/4. Okay, so let's see, we've got 2 times, it's probably negative 3/4. So we've got 2 times negative 3/4 divided by 1 minus negative 3/4 all squared. And I'm going to leave the 4 in the denominator. I'm going to write 2 times negative 3/4 as just negative 6 over 4. And that's because I know what's going to happen in the denominator. I've got a 4 squared here. So I've got 1 minus, and this negative goes away. So we've got negative squared is positive. And this is really important to remember. These negatives don't talk to each other yet because we've got to square first. So when we square, we get a positive, and the negative in the middle stays. 3 over 4 squared is 9 over 16. And I left a space because we want to multiply 1 by 16 over 16. To get rid of the inside denominators, we're going to multiply this whole fraction by 16 over 16. 16 divided by 4 leaves 4. And here we've got 16. So 16 divided by 16 is just 1. So in the numerator of this big fraction, we've got negative 6 times 4, so negative 24. In the denominator, we've got 16 minus 9. Because the 16's in the denominator of the denominator divide out. 16 minus 9 is 7. So we're left with negative 24 over 7, which is exactly the same thing we got when we took sine 2 alpha and divided by cosine 2 alpha. So yay, that's wonderful. And I'm going to pause or stop the video so that we can do the half angle formulas in a separate video.